Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a topic from energy control. The name of a topic is diversity interchange. Now already we have gone through the types of interchange. In that we are going to discuss about a point that is diversity interchange. In short, we can say peak load at different time blocks in the neighboring area. Now let's have a discussion in detail about this. Let us consider that there are two cities. Now there is a biggest time difference between the two places in the United States are the locations which lie under two time zones, the Hawaii Aleutian and Eastern time zone. The difference in the time between the two time zones is the 6 hours. So let's say suppose in a one time zone there is a time that is morning 10 a.m. and as a 6 hours difference is there, so in other city it might be a 6 p.m. Now we know that there is a difference in the peak load demand which depends upon your time. We have gone through the load curve which will be the time on the x-axis and on y-axis will be a total load demand. So this is the case if these two states or these two cities are interconnected with each other. Whenever there is less demand in the one city, then whatever surplus power will be there, it will be given to the other city which will fall under a different time zone and the demand is moved, and vice versa. This is the one case with a different time zone. And the second case is different weather condition. Let's say suppose Florida and the Michigan. Suppose there is a summer in the Florida and winter in the Michigan. So is it possible to transfer the power between these two states? How it will be possible? Let's see in the diversity interchange. When two areas have a peak power requirement at a different time zone, please remember this is very important. This is the basic definition of a diversity interchange. When two areas have a peak power requirement, when it will be, condition is that it should have at a different time zone or at a different weather condition, then it may enter into a diversity interchange. Different time zone includes two areas having different characteristics and types of the loads in the two areas, and it may also include that two areas span in a different time zone. The interchange of the power in such a case would be in both the directions. So let's say there is a system A, or you can say city A, this is a city B, there will be a power transaction between these two. Consider that the two systems or the two cities will operating in a different time zone or a different areas. When the system A is facing the peak load, that is the peak demand at a different times, it should buy the power from a system B. But the condition is that system B should not have its peak load demand at the same time. On the other hand, if the system B is facing its peak load demand, then it could buy the power from system A. This is what is the basic motto of diversity interchange. Please keep in mind, whenever the peak load requirement is there, but at different time zones or different weather conditions, then the interchange agreement which will place in between the two systems will be a diversity interchange. Let's see, this is a diagram of a US, we can say US map. Here you have seen that the time zone is different for a Pacific time, Mountain time, Central time and Eastern time. So if it is interconnected, there will be a change in the loading condition. Now let's have an example here. The United States is divided into 9 standards time zone. Okay, 9 standards time zone. So here we'll take an example of India. If you see here, the recast hourly demand figures for the states and union territories with the groupings under 3 time zones which are shown here in the table. This table here I have taken from one paper. So you have seen that at 1 we can say 1 o'clock, at 2 o'clock, at 3 o'clock, what is the demand here in Arunachal Pradesh, in Nagaland, or in the different zones, different time zones of India. Again here we know in Delhi the sunrise will be at 5:23 am, but in Arunachal, which is near to the eastern region, it will be at 4:20 am. So if you see there is no as such a time lag or a time difference, not more than 1 hour. So here it is not possible. But the countries wherein there will be a time zone, or there will be the changes in the time in between, let's say 6 hours or 8 hours, the gap is there. So in that case, such kind of diversity interchange will take place. Again, this is the example where you have seen time zone 2 GMT plus 5:30 here. So there are few cities wherein the demand has been given here. Now, if two systems experience such a phenomena, they can help each other by interchanging the power during its peak hours. The system that peaked first would buy the power from the other and pay it back when the other system reached to its first load. So let's say, suppose the requirement of a power for A is more. It reaches to the peak demand first, and now for a next load demand, the power is required. Then it would buy it from a B, or vice versa. And whenever there is no requirement, if surplus power is there, then it will transfer it back to the utility from where it is purchased. Daily diversity interchange agreements may be made between two large systems covering operating areas that span at a different time zone. This type of interchange may happen during different seasons of the year also. Typically, different seasons means what? Different weather conditions. Typically, we know that when we talked about a summer condition, then the load is more because of air conditioning. And let's say if the other system, whatever example we have seen previously, system A and system B. Suppose the system A or city A, wherein there is a summer, and in the city B there will be a winter. Wherever there will be a summer, the load of air conditioning will be more because of hot conditions. Wherever there will be, we can say winter, there will be a load which will be a heating load. Now, the winter peaking system would buy the power during winter due to the high heating load from the summer peaking system. Because for the summer peaking system, the presumable load may be lower during the same time of the year. Then in the summer, the situation is reversed, and the summer peaking system may buy the power from the winter peaking system. Thank you for watching this video. It clears the topic of diversity interchange.